Density is a ratio of mass to volume of a particular object. And it doesn't matter whether we're talking about an element or a mixture of things. We can set a density if we have a known mass and a known volume area. So density can be very useful in understanding the behavior of matter, particularly in its physical properties. It has also traditionally been used to help identify an unknown substance by the way that its density value may resemble that of a known substance. That's not always perfect, but it has and continues to be a good way of helping identify substances that may not be known for what they're made of. So we have an example of two objects here. We have a metal standard weight of 200 grams, and this is probably mostly made of iron. And here we have a piece of pine wood. So although the pine wood makes up more actual volume, it takes up more space if you view it from the outline of its total area. It is far less dense than the metal is. And density has basically been, like so many other things in our modern metric systems of measurement, is been built around the properties of water. Water at standard conditions, which is standard atmospheric pressure and about 0 degrees Celsius, will occupy 1 milliliter of space for every gram of mass. We can also view the density several other ways in what's essentially the same ratio: 1 gram to a milliliter, 1 gram to cubic centimeter, or multiplying each of these by 1,000, 1 kilogram to 1 liter. So, but essentially the ratio is the same. One trick that students tend to have a problem with when studying this in high school is really paying attention to whether a question is addressing something in grams or kilograms or cubic centimeters or milliliters or liters. Lots of tests and homework questions and standardized test questions tend to play on the issue of whether or not students are really paying attention to which value is being used or asked for based on the information provided. So we see that water acts kind of for a lot of everyday measurement in the sciences as sort of a standard of which other things get measured. Because water has a density of 1 at standard conditions, we can pretty much guess whether an object is going to float in water or sink. If we have a density of less than 1, like this wood, the object will float, and if the density is greater than 1, the object will sink. Or if we viewed this as density equals mass over volume, and A equals B over C relationship, A being the density, B being the mass, and C being the volume, if C is greater than B, you're going to obviously have an answer A of less than 1. And if B is greater than C, we'll obviously have an A that is greater than 1. So another thing that you really want to be thinking about as we get into this material is sharpening your math skills in general. Starting to notice very obvious mathematical patterns, not just as a way from understanding, but also able to catch mistakes. Very often when students are trying to manipulate a relationship like this, they may put the numbers backwards in the calculator or something like that, and you can catch those mistakes. For example, if you have a situation where you have, let's say, a situation here where we have a mass of 1 gram over 4 milliliters. So if we do our math correct, we know that our density is going to be 0.25. So this is going to be a very low density object, 0.25 grams per milliliter. But very easily, we will find ourselves flipping our numbers backward in the calculator. So we might do 4 divided by 1 and getting instead an incorrect answer of a density of 4. But if we're really paying attention to very basic mathematical relationships, we'll see that's impossible. Just by eyeballing and saying, hey, our numerator is less than the denominator, our answer has to be less than 1, that helps us catch the mistake and say, oh, I entered the calculator wrong. Do it again. 1 divided by 4, and it's 0.25, and this makes sense because, as we know, any fraction where the number on top is less than the number on bottom, we're going to have an answer less than 1, and then if we have the number on top, the numerator greater than the number on the bottom, it has to be more than 1. So as we're getting into what is a scientific concept, let's really start focusing also on strengthening basic math concepts. Not only for one understanding, but also to help catch those careless mistakes that you, me, and everybody else makes all the time.